Hello everyone. In this short lesson, we will review some of the basic techniques in integration that will help you to be very successful in this class. Um, Understand that integration is a technique that is used for calculating the area on the graphs. What I mean by that is if we have, for example, a function represented by that curve. This is a function y equal to f of x. Suppose we want to calculate the area bounded by 2 points A and B. Now, I'm not really going to go into details on how this came about, the derivation, which is actually kind of fun. The area here, A, is totally given by the integral from A to B of f of x dx. In other words, integration provides a means through which we can calculate the area bounded by a graph as long as A is less than or equal to x, which is less than or equal to B. But the real deal that I really want you to remember is that integration is an antiderivative. In other words, the integral of a function is the antiderivative of that function. For example, if we have a function y equal to x cubed, therefore dy over dx will be equal to 3x squared. Because integration is the opposite of differentiation, it means that if we integrate 3x squared, our answer has to be x cubed. In other words, the integral of 3x squared dx will be equal to x cubed. I'm going to add here plus c. I'll explain later. Similarly, if we have y equal to 3x cubed plus c, the derivative dy dx is just going to be 3x squared. That would mean that the integral, that would imply that the integral of 3x squared dx is equal to x cubed plus c. In the same way, if we have y equal to 2x cubed plus x, then dy dx will be equal to 6x squared plus 1. What this means is that the integral of 6x squared plus 1 dx will be equal to 2x cubed plus x plus c. In other words, integration is the antiderivative of a given function. It is important you understand this. It is really important you understand this. So we're going to do some examples, some more elaborate examples for you to understand. Generally, the integral of x raised to the power n dx is equal to x raised to the power n plus 1 divided by n plus 1 plus c. This is the first formula that you should always remember when you hear the word integration. For example, the integral of x squared dx is equal to x2 plus 1 divided by 2 plus 1 plus c, which is equal to x cubed divided by 3 plus c. Similarly, the integral of 3x squared plus x dx is equal to the integral of 3x squared dx plus the integral of x dx. This is equal to 3 bracket x cubed divided by 3 plus x squared divided by 2 plus our constant c. So if we simplify here, we're going to have x cubed plus x squared divided by 2 plus c, and that will give us our answer. Similarly, if we have the integral of 4x squared dx, this is the same as 4 multiplied by x cubed divided by 3 plus c. This is just equal to 4 over 3 x cubed plus c. Now, if we have the integral, let me say, of x cubed plus 2x dx, this is the same as the integral of x cubed dx plus the integral of 2x dx, which will be equal to x4 over 4 plus x squared over 2 plus c. And if we simplify this, this will be x4 over 4 plus x squared plus c. And that is our answer. Now, this right here, the integration without limits, is what we call indefinite integration. Indefinite integration. On the other hand, for definite integration, let's do an example. The integral from 0 to 1 of x plus 2 dx. Before I proceed, it is worthwhile for you to understand that the integral of a constant a dx is just going to be ax plus c. So the integral of a constant will yield a linear function. So this will be equal to the integral from 0 to 1 of x dx plus the integral from 0 to 1 2 dx. This is x squared over 2 from 0 to 1 plus 2x from 0 to 1. Another way that we could put this is x squared over 2 plus 2x from 0 to 1, which means that you have here 1 squared over 2 plus 2 multiplied by 1 minus 0 squared over 2 plus 2 multiplied by 0. So this will give us 5 over 2 minus 0, which is just equal to 5 over 2, and that will be our answer. And that will be our answer. Let's do some more examples. The integral from 0 to 1 of 3x squared plus 2x plus 1 dx. This is the same as 3, the integral from 0 to 1, x squared dx, plus 2, the integral from 0 to 1, x dx, plus 0 to 1, multiplied by dx. This will give us 3, x cubed over 3 from 0 to 1, plus 2, x squared over 2 from 0 to 1 plus x 0 to 1, which will be equal to x cubed plus x squared plus x bracket. We're integrating from 0 to 1. All you have to do is substitute the upper and the lower limits. So this is 1 cubed plus 1 squared plus 1 minus 0. And this is just going to be equal to 3. So if this was a function, which it is, then 3 is the area bounded by what? By the boundaries 0 to 1. Now, in the next couple of minutes, we are going to take off some time to look at how to differentiate exponential functions. Keep in mind that the derivative d dx of e raised to the power x is just e raised to the power x. That means that the integral of e raised to the power x dx is just equal to e raised to the power x plus c. Similarly, we know that the derivative d dx e raised to the power f of x is equal to f prime of x e raised to the power f of x. This means that the integral of f prime of x e raised to the power f of x dx is gonna be given, is given by, or is equal to e raised to the power f of x plus c. I can give you an example. Suppose you are asked to integrate e raised to the power 3x plus 2 dx. So we realize that there is nothing in front of e, but if we say that f of x is equal to 3x plus 2, this would mean that f prime of x is equal to 3. Therefore, the integral will become 1 over 3, the integral of 3e 3x plus 2 dx. You see that I've divided by 3 and multiplied by 3, which means that this essentially is being multiplied by 1. And anything multiplied by 1 is itself. So this will be equal to 1/3 e 3x plus 2 all plus c. And that will be our answer. And that will be our answer. We know that the derivative of ln x is equal to 1 over x. This would mean that the integral of 1 over x dx is equal to ln x plus c. Ln x plus c. Similarly, we know that the derivative of ln f of x is equal to f prime of x divided by f of x. That means that the integral of f prime of x divided by f of x dx is going to be equal to the natural log of f of x plus c. This is important, and it's good that you should take note of it. Let me give an example. Let's say we want to calculate the integral of dx divided by, let's say, 3x plus 1. Does it look like this function? No. So the very first thing we will say is that f of x is equal to 3x plus 1. That means that f prime of x is equal to 3. That means that f prime of x is equal to 3. Hence, we can rewrite that function as 1 over 3, the integral of 3 dx divided by 3x plus 1, which is just going to be 1 over 3, the natural log of 3x plus 1 plus c. And that gives you our answer. Similarly, if we have the integral of dx, ax plus b, all you have to do is let f of x be equal to ax plus b. that means that f prime of x is just going to be equal to a. Hence, we can rewrite this as 1 over a, the integral of a dx, all divided by ax plus b, which is just going to be 1 over a, the natural log of ax plus b plus c. And that will be your answer. One last example, the integral from 0 to 1 dx divided by 5x plus 2. This is the same as 1 over 5, the integral from 0 to 1, 5 dx divided by 5x plus 2, which is the same as 1 over 5, the natural log of 5x plus 2 from 0 to 1. Hence, that integral will be equal to 1 over 5 bracket the natural log of 7 minus the natural log of 2, which is equal to 1 over 5 the natural log of 7 divided by 2. And that will be our answer. Thank you for your time, please.